In this lesson, we're going to go over an example motivating the binomial distribution formula. So to motivate the formula, let's consider this example. Suppose we have a very large population of people in which we know that 10% of them are left-handed. Now suppose we randomly select 6 people and let X denote the number of left-handed people that we get in that selection of 6 people. Suppose we want to find the probability that 2 left-handed people are selected in the 6. So suppose we want to do that. Alright, now the probability of getting a left, left, right, 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 right in that exact order, so you draw 6 people, the probability of getting the first person being left-handed, the second person being left-handed, then the third, fourth, fifth, and sixth person being right-handed is going to be this by the multiplication rule. You see, the probability that the first person selected as left-handed is 0.1 because 10% of the population is left-handed. And then the second person being left-handed. Okay, so we multiply 0.1 times 0.1. You see. And then the third person is right-handed. Well, that's going to be 0.9. And we multiply these together because notice I'm using the word and in here. And then the fourth person is right-handed. And then the fifth person is right-handed. And then the sixth person is right-handed. So you see we multiply all these numbers together and that's going to be the probability of this occurring. And we see that that is 0.1 squared times 0.9 to the 4th power. Alright, now we want to know the probability that 2 out of 6 of the people are left-handed, but we don't care about ordering. So you see this is only one of the ways of getting 2 lefties and 4 righties in a selection of 6. But we don't care about ordering here. So what we have to do is find out all the ways of ordering 2 left-handed people and 4 right-handed people and add the probabilities together. You see, because we could get left, left, right, 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 or we could get left, right, left, right, 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 or we could get right, left, left, right, 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 or, and you see when I use the word or, that means I then use the addition rule instead of the multiplication rule. So that means I have to take the probability of this plus the probability of getting this outcome plus the probability of getting this outcome plus the probability of getting this outcome. Now you notice one thing about all these outcomes, they all have the same probability. You see, the probability of getting 2 lefties first and then 4 righties is the same as the probability of getting a right, right, left, left, right, right. All I do there for this probability is I change the ordering of the 0.1 and 0.9s up here, but that doesn't matter when I multiply. So all of these probabilities are the same. So now what we have to do is figure out how many orderings do we have of this outcome, and then just multiply that number by this. And that'll be our answer. Well, think about it like this. So how many arrangements are there of left, left, right, 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 right? Well, you see what we have in this situation here is the 2 left-handed people are assigned to positions 1 and 2. But they could also be assigned to positions 1 and 3, like right here. They're in position 1 and 3, or they could be assigned to positions 2 and 5, and so on. So the total number of ways of assigning the 2 left-handed people to the 6 possible positions is 6C2. You see, we're selecting 2 numbers from the numbers 1 through 6, and ordering doesn't matter. You see, because if we select the numbers 1, 2 and assign the left-handed people to those positions, well, it doesn't matter if I assign them to 1, 2 or 2, 1 because they're both left-handed people after all. So the number of arrangements of this is then going to be 6C2. Oh, and one other thing, you notice once we assign the left-handed people to their positions, then the other right-handed people, they just fall right into the remaining slots. So we don't have to worry about, oh, where do we assign the right-handed people? We only assign the left-handed people, then the right-handed people are automatically assigned to the remaining open slots. And so we see then that the probability of getting 2 left-handed people in 6 selections is going to be 0.1 squared times 0.9 to the 4th times 6c2. This determines how many arrangements there are of the letters left, left, right, 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 like that. And you see, this exactly follows the pattern ncx times p to the x times q to the n minus x. The n is 6 in this case, the x is 2, the p is 0.1, the x is 2, the q is 0.9, n minus x, 6 minus 2 is 4. And so you see that's exactly where that formula comes from. So that's the motivation for why we use this formula for the binomial distribution. And that concludes this video.